simulate 100% the final target. With I2ST technology, we proudly say now that the simulator simulates at 100% the future target, because we embed into a PC workstation a copy of the JVM that will be in the end present in the target, and we embed in the PC workstation also the same libraries. So the environment you use to develop your application is 100% the same that will be present in the end in the target. This simulator offers also the possibility to connect your PC to real hardware like sensors, activators, or peripherals in order to simulate and test the functionality of your application on the PC. If you are not willing or able to connect your PC to real hardware to have real stimulation or real data input, you can, of course, simulate this type of inputs, what we call hardware-in-the-loop simulation. Now, if you understand right, our customer can use micro EG as an Eclipse workbench and development tool. They can use S3 to simulate their future target and optimize a Java application for an embedded system. And the biggest argument is to say, once you developed this application, it's fully 100% portable at binary level, whatever the target is. Assuming the target is porting the corresponding JVM. So our customers quite quickly understood that this technology is interesting, that they are kind of bound to I2ST if they want to reuse the Java application and port it onto different targets with different peripherals and stuff like that. They need to get a new Java virtual machine from us. So we now offer the micro BSP for Java platform design, which allows you to customize an existing platform with a JVM and libraries. So you can reuse this platform for a new product, a new device with different peripherals. So once again, this tool, we use Eclipse as basis environment development. We use Jazz RTC for the planning and multi-source control. We use some of the Eclipse features, the JDT for Java, the CDT for C, of course, and we customized the JDT for the language I2ST. And as well, we offer I2ST plugins, which are, for instance, class val inspector, and the customization of the existing Java native interface. We call it fast native interface. So this is basically how it will look like. We simulate graphically and functionally your target. The design of this simulator was done in 2 days, and the trainee was done with simulator, needed 2 additional days in order to get used to the tools, to micro EG and micro UI graphic interface. So we decided to develop this simulator because we were offering for each existing hardware target we support, Atmel, NXP, and I2ST, we supply the corresponding simulator. But of course, this cost money, and we had many demands for free evaluation of this technology, so we decided to offer this free simulator, which is based on a fictitious target. This target is not existing, there is no real hardware corresponding, but it shows usual peripherals like a text display, graphic display, potentiometer, buttons, LEDs, which allows you to test your application on a simulated embedded target. So this is how it works. We simulate on the PC the touchscreen with the mouse, for instance. We even decided to simulate the light sensors, for instance, temperature sensors. So you really have in front of you on your PC your final device. You can play, you can test, you can, if you want, bound it to hardware for input sensor activators. Alright. And this is an example, maybe I will switch to the real simulator. So there we use the launch environment Eclipse. And this is the simulator we done for the NXP LPC 2478 board.